Alright everyone, so in this video I will be helping you, save my space here. I'm going to be helping you answer the free response questions for the Unit 1 midterm review. Alright, if you check this midterm review answers document that I've uploaded, you will see that I've provided the answer to the multiple choice questions with explanations, but I feel that the free response questions require a bit more in-depth of an explanation, hence this video. So let's go through this now. Again, the goal here for this midterm review is that you try to answer the questions yourself first to the best of your ability. All right, first, do it off the top of your head. See what you know already. Then use the notes to go through and check your answers. And finally, use this sheet that I've given you, this digital worksheet and video, to check the actual answers. All right, so let's go through it. First question of the free response: explain what separates a good hypothesis from one that is bad. Now, you'll recall that this is something that we did during the Mentos and Coke lab, where you had to formulate a hypothesis about what caused the Mentos and Coke reaction. And you couldn't just come up with any idea. It first of all had to be testable. All right, it had to be testable. The hypothesis had to be something you could test in a lab environment or some way prove it right or wrong. Secondly, it had to be falsifiable. You're going to learn how good I am of a speller here, all right? Falsifiable means your hypothesis needs to be something that could be proven wrong. There must be some idea going in where if you hear the right piece of information, you'll be like, oh, that idea is wrong. So a good thing would be for the Mentos and Coke, for example, your idea is that this explosion only works with Diet Coke. Well, the simple test here is to see if it works with regular Coke. And if the explosion works with regular Coke, then you know your idea was wrong. It was both testable and falsifiable. On the other hand, if your idea as to what causes the Mentos and Coke explosion is magic invisible fairies get angry at you for throwing Mentos in their Coke and then cause it to explode, well, there's no way to test or prove that wrong. You're basically just saying magic. So a good hypothesis has to be something you can test, and there must be some information you can test for that if you find it, you admit your hypothesis is wrong. All right, so next up, what would be an example of a chemical reaction? Provide 3 pieces of evidence. All right, well, let's, geez. 1 second. All right, so what would be an example of a chemical reaction? Well, a chemical reaction is anything that atoms disconnect and reconnect to form something new. But you can't see atoms doing that directly, so you need to look for alternative pieces of evidence. So I'm actually going to go backwards. I'm going to give you some pieces of evidence that demonstrate a chemical reaction is occurring, and then we'll think of an example. All right, so the first piece of evidence is a change in physical properties. All right, so things like if a new color appears, all right, or a new smell or a new taste, all right, or maybe the substance becomes harder or softer, all right, or I don't know, it becomes more brittle, all right, or more malleable. What are some other things? Oh, it becomes magnetic, all right, or non-magnetic, all right. Basically, if any of these properties change, you're looking at evidence of a chemical reaction. When something's color changes, that usually means the atoms have reconnected to form something new, or smell or taste, right? So that all counts as one category of observable evidence. Another thing you'll see is that energy is absorbed or released, right? Every chemical reaction requires some kind of change in energy. When you disconnect and reconnect atoms in a new way, you either have to put energy in to make a new arrangement, or they will release energy as they find a new, more stable arrangement. So energy is absorbed or released, like, release heat, light, flame, etc. All right, some release in energy, or It absorbs heat. You know, you don't really think about this, but cooking food, for example, or chemical reaction, cooking food is a reaction that requires heat to be absorbed. A piece of meat won't cook itself. You have to put energy into it to rearrange the molecules. And lastly, cannot be easily undone. All right? When you go through the effort of rearranging the atoms in a compound, they usually are rearranging because they found a more stable way to be, and they will not change back easily. Think of it like knocking down a bunch of dominoes. They'll fall down easy, and now that they're laying down on the ground, it is very hard to set them up again. Not impossible, but not easy. So when we think about this, things that change color, smell, taste, all right, become harder or softer, things that absorb or release energy, things that cannot be easily done. The easiest one that I can think of is a burning paper or a log or anything, all right? When you burn something, it is changing color, smell, taste, all right, is releasing heat, light, and flame, and you cannot unburn it, all right? Something similar is, like I said before, cooking meat, all right? When you cook meat, color, smell, and taste change. That's why we cook it. It requires energy to be absorbed in order to happen. The meat won't cook unless you put it on a hot stove or grill, and you cannot uncook the meat, all right? What else? Rotting cheese, all right? The smell, color, taste all change. Energy is released, all right? And it cannot be easily undone. Now, for rotting cheese, all right, rotting cheese right here, you might not be able to tell that energy is released because it happens very slowly, but it does happen. And that's a good point to bring up here. Not all chemical reactions are easily observable in all these pieces of evidence. But if you can find 2 pieces of evidence or more, then you have a pretty good candidate for a chemical reaction. Another one would be, classic rusting metal. Can't unrust it. All right. Name 4 pieces of lab safety equipment and what they should be, or when they should be used. All right. So let's go through some of this. Yes, there will be lab safety questions. Goggles. All right. When working with glass, heat, chemicals, anything that could damage your eyes. Eye wash. All right. When chemicals get in your eyes. Apron. Caustic. That means things that can dissolve flesh. Caustic, or dangerous chemicals. All right. Or hot water. All right, hot water. And so forth. You've done lab enough. You could name a few pieces of lab safety equipment. All right. Next up, we have this chemical reaction right here. All right. C6H12O6 breaks down into 2 C2H6Os and 2 H2Os. This is, or CO2s. This is sugar breaking down into ethanol and carbon dioxide. This, my friends, is fermentation. This is how alcohol is made. So what are the products in the above reaction? Well, the products are what you end with. So in this case, the products are this substance right here and carbon dioxide. All right, those are the products because they are on the right side of the arrow, right side of the yield arrow. All right, I'll write that in. Anything to the right of the yield arrow. Good. All right. And what elements make up the reactant in the above reaction? Well, only 3 of them. All right, which you can tell because they are capital letters. You've got carbon, hydrogen, and oxygen. This might have been a hard problem at the beginning of the year, but at this point, we're pretty good that this reactant is comprised solely of 6 carbon, 12 hydrogen, and 6 oxygen. All right, so with that, we have answered the multiple choices. You can check those answers online and walk through and explain the free responses. Thank you for your time.